Okay, we should be live. So hi everyone, welcome to the first afternoon session of SCAI. And this session is going to be chaired by Verena Rieser. So Verena, go ahead, you have the floor.
Hi there. Yeah, it's my pleasure to chair the session. So this session is about user preferences. So in particular, extracting user preferences, personalization of information access, and advances and challenges for personalized dialogue generation. So that's the broad topics. We've got 4 paper presentations today. Each of them lasts about 10 minutes. And then afterwards, we've got a panel discussion on these topics, which I will moderate. There's also hopefully time after each talk for some short question answering, so please submit your questions in the chat. And the very first presentation today is from Sergey Volokhin. I'm not sure whether I pronounced this right. Sorry about that. So Sergey is a second-year computer science PhD student at Emory University. And today he'll be talking about watch drama movies towards predicting movie preferences from conversational interaction. Over to you, Sergey.
Hello, everyone. Well, I'm already fourth-year PhD student by now, but that's okay. So I'm, again, from Emory University. I work with Eugene Eggestein. So let's start from the beginning. What we're trying to do is infer user preferences through a conversation in order to make an effective recommendation. And unfortunately, there was little data available at the time for such a task, so we are also releasing the dataset as well. So more formally, given a prefix of a conversation of several turns and mention of M movies, we aim to predict M plus first movie rating for the user. In this experimental setting, the value of M is set to 2. So basically, we're given the mentions of 2 movies, we're trying to predict users' rating towards the third movie. Our setting differs from prior work in that the user isn't actively seeking a recommendation, so the conversation doesn't have to be a rigid template-based format. It can be a free-form, natural-flowing conversation. Our contributions are twofold. First, we develop and make available a finely annotated conversational dataset for movie recommendation, which we call Movie-Cent. We annotate it with entity IDs linked to Rotten Tomatoes website and fine-grained user sentiment. Secondly, we propose a new conversational recommendation method, which we call conversational collaborative filtering using external data, or Convexter for short. This method estimates user sentiment towards the first 2 movies using the conversation and predicts user score towards the third movie from the conversation, leveraging an additional external dataset of reviews and ratings. So again, we have a Movie-Cent dataset, Convexter method, and there is another unnamed dataset of reviews, which I will explain later. Here are the details of the Movie-Cent dataset construction. We extended the existing datasets based on the paper Coached Conversational Preference Solicitation introduced by Philip Wardlinski et al. In 2019 to make it amenable to perform experiments in conversational recommendations. The original dataset is a collection of conversations about movie preferences in free form. To construct the dataset, we first removed those conversations which have fewer than 3 movies mentioned, because again, we are trying to predict the third movie's score. Secondly, we annotated each movie in those conversations with their unique IDs from Rotten Tomatoes, as well as a fine-grained user sentiment labels towards the mentioned movie. Annotations were performed on a -3 to +3 scale, by independent judges with the 20% overlap, and at most 2 people labeled the same sample. Here are some examples of utterances from the dataset with their sentiment scores. The first 2 columns were taken from the initial CCPE dataset, and the last 2 columns are our annotations. In the last row of the sentiment label is none, because the user expressed no sentiment towards the mentioned movie. That was also one of the possible annotations. The resulting dataset is small, but it is enough for our initial analysis. We calculate interreliability using the weighted covariance kappa, which equals 0.77, which indicates substantial agreement. External data that we have used is critics' reviews from Rotten Tomatoes, which were scraped. And here are the statistics as well. So to estimate user sentiment towards the mentioned movies, we train a random forest regressor. We use conversations from the original dataset CCPE. They did not get into our dataset for training. We use pre-trained uncased BERT-based to calculate the embeddings of those conversations. Resulting model gives us RMC of 0.88, which is sufficient for current work. And we use those estimates together with a large set of external critics' ratings and reviews to create the collaborative filtering model. Our research, this is the critic item interaction matrix. So basically what we are trying to do is use the random forest model from the previous slide and add the conversational user in the interaction table as a new critic, learn the collaborative filtering model, and try to predict the score for the third movie using that model. You can choose any CF flavored model you desire. We have chosen SVD++. And again, so we apply it to get the estimate for the last movie, which is the score. Our research indicates that the critics who are paid professionals significantly differ from conversational users. Therefore, we cannot use just the raw CF score, which we get from the previous slide, and we have to use other features to adapt from critic space to user space. So firstly, we index all the textual reviews and query the conversation using BM25 metric to retrieve most relevant critics to the conversation. Then we calculate a weighted average of the BERT embeddings of textual reviews for all of those selected critics. And we calculate the cosine similarity and Earth movers distance between critics embeddings and conversational embeddings using BERT. We use those 2 scores as features in our final model. Another several features are using movies metadata. So we take the metadata for the movie in question, like genre, title, actors, etc. There are 7 metadata features in total, and we get their separate embeddings. And we calculate the cosine similarities of each one of those with the conversational embedding we got earlier. The resulting scores are added in the model as features as well. So we will have 7 additional features, 1 per each metadata type. The final model uses those 3 groups of features. So first, we have one feature is the CF prediction for the unseen movie. Second is 2 features representing similarity of the conversation to critics. And lastly, the 7 features represent similarity between the conversation and the metadata of the movie. We use gradient boosted regression tree as a final model. And here we have compared our method against 2 baselines. First one consists of taking an average of the critic score for the movie we are predicting the score for. And second one consists of taking the average of the audience rating. We can see that the audience, which is comprised of regular users, is closer to our conversational users than the critics are. For our method, we have tried several algorithms for collaborative filtering, and the best one was using SVD++. The complete model achieved the result of 1.09 RMSE, and the improvement over the baseline is statistically significant. Finally, we have tried to simulate the best performance possible by using the true sentiment labels instead of estimating them using the random forest model, and we got the best result of 0.84 RMSE, so that we can compare it to how good the model is compared to how it could have been. In conclusion, our results demonstrated that incorporating conversation content to select a more similar group of users for collaborative filtering improves the recommendation performance compared to using the inferred ratings alone. Together, our contributed dataset and experiments and the resulting insights offer promising direction for improving conversational recommendation systems through augmentation with external data. This work was partially supported by a grant from Amazon Alexa. And here is the QR code to the code and to the data sets that we release. Thank you.
Great, thank you very much. This was a really interesting talk. We're right on time. So we've got a question from Andre here. So he asks, Sergey, how do you convert the movie metadata for BERT?
We basically concatenate all the, so again, there are several types of metadata. So we have title, we have description, we have actors, we have genre, etc. So for all of those, we concatenate all the elements. So if there were 10 actors, we concatenate them using a comma to separate as a delimiter, and we feed them into the pre-trained BERT base uncased embeddings, and we just get the resulting vector.
Okay, so, okay, Andre says, got it, thank you. So I've got a question. What interests me is how did you actually, so as far as I understand, you estimate, first of all, from these existing conversations, how much a user sort of expresses liking or disliking a certain movie. And that's on a scale, and then you ask people to annotate this. So you've got these judges who look at it and say, on a scale from -3 to +3, how much this user likes or dislikes a certain movie. And you said you had a really high annotator agreement score of 0.7 something, which really surprises me, because it's this translation between expression of liking something to a specific score on a scale, from my experience, this is a really hard task for people to do. How did you do that? How did you train your annotators? How did you get such a high agreement score on this task?
Well, I think the fact that those judges were also PhD students helped. So we just showed some of the examples which could help differentiate the scores better. So basically we said, we wrote some guidelines, like if there is a strong preference, if the user mentions that it's their favorite movie, then it should be most positive, and then it kind of goes lower with sentiment.
I see. So +3, it's my absolute favorite. +2 is, oh, I quite liked it. +1 is like, oh yeah, I don't mind it, or something like that.
Yeah.
Okay.
Exactly.
Okay, I see. I see. Great. So do we have any more questions? Otherwise, I think we swiftly move on to the next talk. We're going to see you later again at the panel discussion. Thank you again for this really nice talk. So next, we've got Yates from the University of Amsterdam. As far as I understand, Andrew just joined the University of Amsterdam as an assistant professor at the Information Retrieval Lab. And today he's going to present a paper entitled, "You Get What You Chat, Using Conversations to Personalize Based Recommendation." Over to you, Andrew.
Great. Thanks for the introduction. So yeah, I'll present You Get What You Chat, published at ECIR 2021. This is work with Gazale, who's a PhD student I co-advise back at my old institution, MPI, Max Planck Institute for Informatics, with Gerhard Weiku. She's presenting in another workshop today, so I will present the slides. So the problem setting we're looking at today, we call search-based recommendation. By this, we mean we want something like an entity level recommendation, but we don't want a general recommendation. We want a recommendation with respect to some medium grain query. So for example, rather than recommending a recipe, we might ask for iron-rich vegetarian recipes, or rather than recommending any travel destination given my personal profile, we might recommend a travel destination based on my profile and the query best wine lover destination. So in this setting, we're given a query and a user model, and we want to retrieve entity level items that the user finds both relevant and interesting. So we handle this in 2 steps. Basically, we do some initial retrieval to find relevant items to that medium grain query. And then given those items, we do some re-ranking to, given a specific user, to identify items that are relevant to the user's preferences. So when I talk about user models, there's a few different ways they can be created, and this is really what we explore in this work. So a common way to create user models is with explicit signals, so ratings, likes, and purchases. For example, this is common with collaborative filtering. What we're going to focus on this work is 2 different types of profiles. So the first is signal from some sort of concise user profile. So you can imagine, for example, a questionnaire that a user might fill out. For the travel domain, maybe it asks, for example, where they've been before on vacations, what's their dream vacation, what activities do you like to do when traveling, this sort of thing. And another type of user profile we would call something like implicit signals from online behavior. So for example, clicks, maybe social media posts, maybe chats or other text between users. In this work, we're looking at the chat setting. So we'll talk about user study later, but essentially we have users who talk to each other about a general topic, and then we look at how these chats can be used. So just to reiterate, we're going to focus on these last 2 types, questionnaires and user-to-user chats. So our method here, as I mentioned, is to re-rank some pool of relevant but non-personalized results. To do that, in the first step, we retrieve relevant items to the query. We accomplish this with a site-restricted search, so something like searching allrecipes.com for iron-rich vegetarian recipes. This gives us a set of candidates that should be relevant but are not necessarily interesting to a specific user. And then we have the re-ranking step on top of that, as I described. You can imagine something like a chat being useful. Here we see terms like Italian pasta, potentially useful for food. And what we look at in this work is how well these different types of user models can work and how we can adapt a set of re-ranking approaches to perform this task. So I'm only going to talk about our general re-ranking approaches here. We also look into doing things like adding domain-specific term weights to these approaches or doing some sort of entity expansion of the user model. I'm not going to talk about these tweaks on the approach in much detail here. I'm going to focus on the main methods due to time, but there are more details in the paper. So as I mentioned, we tackle this as a re-ranking problem. So we're given a query, a user, and a document. One thing we could do, for example, is compute a language model using KL divergence. So this would be, for example, between the query language model and document model, and between a user model and a document model. Here, the user model would come from our questionnaires or chats. And then, of course, the query and document models are as normal. So this is one method we look at. We also look at a few other methods that I'm not going to explain in any more detail due to time again. But essentially, you can imagine doing this with something like BM25, or you can imagine doing it with a neural ranker, where we're essentially inputting the user model. So before I talk about how we evaluate the approach, I want to talk a bit about our user study, because this is the sort of data we collected. This was a large part of the effort. So essentially what we did is we recruited 14 participants. Over a few months, we asked them to perform various tasks and collected data. So for example, we asked them to have user-to-user chats on one of 4 topics, so general, books, travel, or food. I should point out that when they're having these chats, the users don't have an idea of what medium grain queries are going to look at later. So they are just general chats on these topics. The users have about 11 chat sessions on average each, and these sessions are about 4,000 tokens per user. The other type of model we obtained is these questionnaires I mentioned earlier. So these consist of 18 general questions, a couple questions on books, 5 on travel, and 10 on food. And so these form the user models that we used. So we collected this data, we ran the user study for a while. Once we had these, we went back, came up with some medium grain queries, ran them to find the initial set of candidate results. And then we asked users which of these medium grain queries they were interested in. They picked the ones they were interested in, and then we asked them to do some subjective relevance assessment or interestingness assessment of these specific queries. So this was on a 3-point scale where the user said that they were strongly, mildly, or not interested in a specific entity. So for example, a recipe for some type of iron-rich vegetarian food. And overall, what this gives us is 113 user query pairs that cover 73 distinct queries in these 3 domains, so books, travel, and food. I should mention that this data set is also available online. We, of course, gave users some opportunity to redact things from the questionnaires and chats and so on before getting to this step. So as far as the experimental setup, I think this is somewhat clear, but just to reiterate, we ran this site-restricted search. This gave us a list of candidate documents, and then we re-ranked these candidate documents using these chats and questionnaires we had collected. When we do this, we essentially assume that we're not going to improve relevance to that medium grain query we started with, so we isolate the effect of the user model. So with something like KL divergence, that means we set alpha such that the query model is not used. The ranking or the re-ranking is done based on only comparing the user and document models. For other methods like BM25, CAN, or M, we just drop the query and input the user model directly for the re-ranking. And again, I mentioned we collected these interestingness judgments, and so this is our evaluation metric, NDCG at 20, but using the judgments of interestingness rather than relevance, so whether a result is interesting to a specific user. Just to give you a quick idea of the larger questionnaire, again, this is available online. General questions like what is your age, family status, where you're from, occupation, travel questions I mentioned earlier, book questions asking for favorite books and genres of books, for example. You could imagine why entity expansion would be useful here. And then user-to-user chats contain, I think they clearly contain terms that are related often. So for example, in the middle, we have food-related terms like biryani, rice, chicken, Italian culture. On the right, we have something about types of books the person liked, crime books, falling in love, modern drama, etc. So I'll talk about 2 research questions today. The first is whether this personalization is helping at all, or to what extent it helps. So this is looking at the query only versus using user models. And the second is which personalization model is best. So should we use the chat-based user model or the questionnaire-based user model? I won't talk about 2 other questions that deal with parts of the method I didn't talk about. So whether we need this domain-specific vocabulary weighting and whether we need this entity expansion. So to quickly show you some results, if we look at query only versus user models, on the left in the gray box, we see the performance using only a query. In the right, in the red box, we see the performance using various user models. So questionnaires or chats, either over all domains or over the target domain being considered, or over that target domain and also the general items. Basically, what we see is regardless of the configuration, all the language model and BM25 improve with personalization. This CAN or M model tends to fail. There are some technical likely reasons for this that I don't want to get into here. But consistently, the language model in BM25 gets some improvement. And what we see is the improvement is slightly better with questionnaires than with chats. So on the left in the red box, you see the questionnaires. In the right on the gray box, you see the chats. Not a large difference, but there is a small improvement personalizing with the questionnaires rather than with the chats. This does vary if we look at individual domains, of course, though. So for example, books only had 2 questions in the questionnaire, so the chats work out better there. So to wrap up, you can check out our paper for these other 2 research questions. Essentially, the spoiler is they may help a little bit, but they are not essential, these entity expansion and domain vocabulary weighting. And to conclude, what we've found here is that personalization via user profiles
so either questionnaires or chats, seems to improve the results in this search-based entity recommendation setting. But the two types of data have some trade-offs. We wouldn't say there's a clear winner. So questionnaires are nice and they're transparent, they're scrutable, you're very aware of what you're revealing about yourself, but it's a lot more effort to keep up to date. You probably don't want to be filling in a questionnaire on every possible recommendation you may get regularly, right? It's too much work. Chats are nice, they're very effortless, but of course you don't necessarily know what you're giving away, and there's some privacy risks here. But both seem to be useful. So thanks everyone for listening. I can now take any questions.
Great. Thank you so much. It was really interesting. And Svetlana has a question in the chat. She said, I missed how the user is represented. A dense vector question mark? And
there is no...
There's a follow-up question. Go on. I will ask the follow-up question. So
the user representation is just tokens. There's nothing sophisticated to turn it into embedding or anything. It's just their tokens. The user model is just a classic language model over all the tokens they've produced in this questionnaire or in this chat.
Okay, so that might also answer the second question, which is, how do you go from chat to a user representation? So that's basically also just the embeddings of that chat.
Yeah, with CANRM, the embeddings of the chat. With BM25, just the actual tokens. So we also looked into ways to expand this representation, which is kind of what I skipped over because they didn't help a lot. So for example, this weighting of terms, you can imagine a discriminative term for one domain is not necessarily useful for another domain. You might have high IDF terms, but if it's about food, it's probably a bad signal for example, a book. So we tried changing the representation a little bit with these methods, but at the end of the day, what I explained here worked near the best.
Okay, that's really interesting. So I have a question about how these two methods, like the chat-based user model and the questionnaire user model, how they exactly differ in why you think, the questionnaire did better. So you already mentioned that, for example, the chat-based one did better when the questionnaire was very sparse. So when there were only like 2 questions in the questionnaire in the book domain, the chat did better because I assume the chat was richer in terms of what the information the user provided. So how was that chat then conducted? And was it basically a questionnaire translated into a chat, or was it an open domain chat, or like how did you get the information you needed in that chat setup?
Yeah, good point. There was very little instruction. So we essentially randomly paired 2 participants and we said, today your chat topic is movies. Go for 20 or 30 minutes or whatever it was. And so we didn't supervise anything more than that. So I think they probably talked about, or looking at the data, they did probably talk about things like what they liked about a movie or a travel destination. So you can see how this is adding terms that I think are useful. Whereas with the book questions, if we only ask for a list of books they like, this requires much better expansion of the entities in order to have the same sort of rich terms that you would get from discussing why you like a book. That's my feeling, at least.
Okay, that's really interesting because it obviously, yeah, the information density in one or the other has to contribute somehow to the performance. So that's possibly then another way to decide whether you go with a user model. It depends, the richness of the chat data you've got available versus what you already know about this user from, sort of more static resources. Okay. Cool, that was really interesting. Thank you so much. Maybe in the interest of time, we move on. Oh, sorry, there was another question. I think we've got a little bit of time. Sorry, that just came in at this very moment when I said, let's finish. Could you fill the questionnaire based on the chat? Oh, that's an interesting question. That's from Svetlana. So it's basically parsing the chat into a questionnaire.
Yeah, I think that would be very interesting. I don't think we can do it with our amount of data. We only have 14 questionnaires because there were 14 participants. But I think this would be very interesting, right? Looking at the chat topics and trying to figure out how these relate to questionnaire questions and essentially presenting the user with like a questionnaire of how we're going to personalize for you, right? This is how we would answer the questions based on your chat. You can look at this questionnaire yourself and edit it and worry about what you're revealing, and et cetera. So it kind of resolves, I think, or would resolve some of these disadvantages of the chat. So it's a very interesting idea.
Okay, yeah, good point. Great, so that was the final question. Thank you again, Andrew. And again, we see each other at the panel discussion. See you later. Okay, so the third talk of today is by Marco Polignano.
Yes.
Apologies again for my German pronunciation. So as far as I know from the internet, Marco is an assistant professor at the University of Bari, Aldo.
Yes.
And he will present a paper today, which is entitled MyrrorBot, a digital assistant based on holistic user models for personalized access to online services.
Thank you.
Over to you, Marco.
Yeah, thank you. Thank you for the introduction. So I'm here today for discussing this work that has been published on Transactional Information System 2021. And so let's start from the beginning. Our idea was to go through the actual trend of personal digital assistants. This kind of software are today always more common in the house of everyone. As example, we have Alexa, we have Google Now, we have many kind of these personal digital assistants that help the user to try to use and to go smartly through some systems and through some services that could be helpful for a task that the user wants to perform. So we can say that in general way, the personal digital assistant is such a meta layer of intelligence between the user interface and the services that are available on the web. So our idea was to try to personalize this kind of interaction with the personal digital assistants through an holistic user models. This means that we want to collect as many as possible information about the user, and we do that by collecting this information through the web. This means that we decided to collect 7 different dimensions of the user profile that are the ones that are here reported. So we have the demographics, the affects, social relation, and so on. And this kind of information are mostly collected from the user profiles that are available on the social media mostly, like Facebook, like LinkedIn, Twitter, and so on. Moreover, we decided that when possible, it is also important to enrich this kind of profile also with health information. So we decided to develop this kind of architecture, this kind of platform that we call Mirror. Here we have a screenshot of this platform where the user can log in, can register, and can go on the platform and link manually, if she wants, her social media identities with our platform. During this process, we are able to go on the social media platform or to the specific user profile and collect all the information that we put all together into this kind of holistic user profile. So this solution has been probably the best from our point, because here the user is able to manage all the information, just go through into the specific dimension of the profile. So the user can click, for example, on interest and decide which kind of interest want to share with us or not. Okay, so on the top of this kind of platform for user profiling, we decided to develop a chatbot, a conversational agent. This conversational agent has the goal of providing access to some very common services that are available on the web, such as music, music providers, video providers like YouTube, and so on. So we decided to provide also through this chatbot also some kind of recommendation about these services by using the information that we have on the user profile, but we also use this kind of chatbot also for managing the whole user profile. In this way, it's not more required to the final user to go into the Miro platform for managing her information, but she can manage them directly from the chatbot. Finally, we performed a user study on our conversational agent that we performed, and we evaluated how much is the usability and how much is the efficiency of the chatbot for providing this kind of services. So this is the whole architecture or MyrrorBot. So we can see here on the top that there is Mirror, our platform for user profiling, as core module of the architecture. Then this kind of framework can provide us access to the user profile that is used by the service manager. What is doing the service manager? It is a module able to select and to query external services in a personalized manner. This means that by using the user profile, we are trying to decide which kind of services and API to call in order to fulfill the user information and the user needs. These user needs are, we can collect these user needs by the user queries that are written to the conversational agent. And in particular, we use the intent recognizer module that is able to understand which kind of need it is required by the user. Finally, when we obtain also the output of the final service that we called, we obtained some elements that are encapsulated into a sentence. This sentence has been generated by the generator module. So let's go a bit deeper into each module. This one is the intent recognizer. As I said, this is the module that has the goal of identify into the sentence what is the need of the user. So here we define into dialog flow different intents that are used for this purpose. So some intents are, as them here proposed, are more focused on the managed section of the user profile. Other are more focused for the use of different external services. So here, for example, we have an example of different intents about music domain, food domain, video domain, and so on. So this is a running example how intent recognizer work. And here, for example, we had the question, where do I live? The intent recognizer is able to identify that the user need is something about the demographic information that are into her user profile. How we did this, we tried to train each intent of dialog flow by providing it a range from 20, 30 possible questions that the user can do to the dialog system. So this is the generator. Here, as I said, this part is about the generation of the answer to provide to the user. And here we use a very simple strategy because we have a fixed part of the answer that is our template and a dynamic part of this template that is fulfilled with the output of the services that we call. What are the services that we included into our chatbot? As I said, there are many of them, and for each of them, we decided to design a specific recommendation module that, in particular, for all the services that we included into our chatbot are rule-based recommender system. This means that we used some information that are into the user profile for activating some rules that allow us to decide which kind of a specific output of the service we have to select and finally to provide to the final user. Here there is an example for Spotify. Here we use the age range, so the age of the user and the physical activity of the user in order to select a specific playlist to suggest to the final user. Something similar has been done for the food domain, here with Giallo Zafferano, a very famous platform for food in Italy, and we use, for example, the height, the weight, the mood, the amount of sleep, and so on, in order to provide personalized receipt. Something similar has been done also for the news and for the workouts. Okay, so we have also the possibility to include new services very easily because the platform is plug and play. So it's just need to define which kind of API to call in order to obtain the output of the service. So how we evaluated this approach that we proposed? We did a user study with 76 people, and we tried to answer to 3 different research questions. The first one is about the effectiveness of the MyrrorBot in supporting the user in daily tasks. The second is about how much satisfying are the recommendations, and the third one is about the usability of the whole architecture. So these are the experimental results. In the first table here, we can observe that the user, by using MyrrorBot, are going to resolve the task more quickly instead of using the simple Google web page for trying to search the service and to obtain the same results. And we have a very big gap sometimes in very complex tasks, such as the video searching, the music searching, or also for the food. Going over, we tried to answer to our second question about how good are recommendations, and here we have also the results. We can observe that by using recommender system and personalized results, we can obtain very good results comparing them with non-personalized way. Here we have, for example, music recommendation, an increment of around 20%. And finally, we have used the SUS questionnaire for perceiving what is user satisfaction about the whole system. And also in this case, we obtain very good results. So in conclusion, what we propose is a MyrrorBot, is a chatbot based on this mirror architecture, that it is a holistic user profile generator. And the future work is about the idea of extending all the services available on this platform, or also to try to improve the dialogue part. So that's all from my side, and thank you.
Sorry, I was muted. That's really great. Thank you so much, Marco. That was a really interesting talk. We don't have any questions so far, but I've got a couple, so let me start with one. So I'm interested in your user study. I missed what the baseline was. So the baseline was a non-personalized result, right?
Yeah, the baseline changes depending by the research question that you want to achieve. So in the first section here, what we try to compare is the user of MyrrorBot, so our interface, compared with the Google classical user interface. So this means that for finding a song by YouTube, the user was trying sometimes to ask this question to the MyrrorBot, and we will try to observe how many times it needs to complete the task. From the other side, the user is using Google for doing the same research query, and we will look how many times it occurs to obtain the same results. It's obvious that sometimes with more complex times, by searching by Google, it's not so easy. So probably the time is higher than the time that is required by MyrrorBot for providing an answer. Here, for example, for the second question, we try to compare recommender system, so personalized answers, with not personalized answer, because the goal was to understand how good are recommendations. And for the third part here, we try to ask the user to say how good is MyrrorBot, so the interface chatbot interface instead of the classic button interface of Mirror for managing her profile.
Okay, I see. Thank you. So it was specific to each of the different experiments.
Yeah.
The other thing which really interests me is this idea of like this auditable user interface. So the user can basically, user profile. So the user can query their own profile, asking like, what do you think my preferences are? Right? I'm often tempted to sort of ask Facebook or Google, who do you think I am? Why do you, show me these adverts? What do you think my age range is, for example, right? So is that the idea? And then would the user also be able to update that? So for example, if they think, you're 80 years old, but hey, I'm only 40, can I then, correct that?
Yeah, that's a true, and that's a good true point, because I think that for GDPR, the European laws about privacy, it's required that the user should have this power of manage her profile. So in order to decide what she wants to share with us, what she doesn't want to share with us, what kind of information she thinks are correct, or what kind of information she wants to change, to update, to remove, and so on. So we provide this kind of opportunity also through the chatbot, but also through the classic button interface.
Yeah, okay. So I don't see any more questions. We are at the slightly running out of time, so I swiftly move on to the very last talk. Thank you so much again, Marco, for your talk, and we see each other at the panel discussion. Right, so the next and final talk of the session is by Professor Lucie Flek. Lucie is a professor at Marburg University, and today she'll be talking about towards user-centric text-to-text generation, a survey. Over to you, Lucie.
Thank you, Verena. So I'll try to keep it brief for the sake of time. How this survey paper came up is essentially that both me and Dee are very interested in personalized generation, and we noted, or user-centric generation, as we like to call it. And we noticed that whenever we talk about personalization or about user-centric NLG, it very often happens that we actually refer to slightly different things. And then we decided to look to many other papers around, and we went through hundreds and hundreds of papers and realized that actually many people mean many different things when referring to user-centricity or personalization. So we decided to try to sort them out a little bit and see what are the prominent understandings of different concepts there. So like generally, if you think of natural language generation on the most abstract level possible, you get some input data, you get some natural language generation model, you get some generated output, and you have some evaluation metric, right? In our case, we mostly think about the input as being text rather than, say, image to text generation also. So when you want to formalize the user-centric generation, you would basically add to this model some sort of user with user U, which provides, or from which you can extract some sort of user information IU, with which you can extract this generation model of yours, with which you can augment this generation model. Now, on the abstract level, this all sounds nice and great and clear, but then we started to ask, what even is user-centric? Like, who are the users of the different natural language generation models in different use cases? So what are whom are we talking about when we talk about personalization? And then we realized that some part of the work talks about personalization to individual language use. So for example, when you take predictive writing models, you want to adjust to the author style, to the author vocabulary, and so on. While when you look at things like personalized machine translation, you will see papers who try to kind of preserve the properties of the original author of the sentence after the translation. So like translating, keeping the gender, keeping the age, keeping the personality, keeping the style. And you will also see papers that might be trying to adjust more to the end user of the system, which might necessarily be the author of the text, which is more the information retrieval or the search-oriented kind of approach, where, for example, in the case of machine translation, you would say, I want a translation that is targeted towards the user of this translation generation system, rather than keeping the personality of the author. And similar in dialogue systems, conversational AI, this maps to the concept of the speaker and the recipient, right? You can think of bootstrapping the persona of the generation model. You can also think of adjusting towards the recipient of the text in terms of providing basically personalized information from the generated dialogue stream. So all this happens in papers when they say they're user-centric or when they say they're personalized. So we try to sort it out a little bit in our paper to various categories. So when we look at who the user is in the dialogue domain, typically personalization is about the speaker. A large majority of the papers is about the speaker, much fewer about the recipient. When it comes to paraphrasing, then it's more about the end recipient of the text. And we also looked into what kind of information is available about the user. How can we structure this information? And that's where we came up with two main categories, essentially factual knowledge and more like stylistic modifiers about the person. And they are also sorted from kind of easier to customize to harder to customize. Typically, the factual knowledge would consist of either user trivia, where you have things like name, location, age, which the model should remember for consistency. And you have preferences, which are influencing the conversation, like beliefs, values, or opinions. And then you have the stylistic modifiers, which are more coming into this category of style-controlled generation, style-controlled paraphrasing, and so on, where you have some situational factors such as formality, politeness, genre, which are influencing the momentary communication goal often. And then you have what we call personal modifiers, which is everything relating to the more long-term representation of the user, like personality and social demographics. And these are typically very clear to express, like saying, okay, this is clearly an extrovert Scottish teenager. But it's very unclear to say how to do the surface realization of these collected labels, right? That's very tricky. And similarly for emotional modifiers, under which we grouped also work on sentiment and partly empathy, even though those are a little bit between categories. These are still very challenging, also because nowadays it often happens through injections or usage of more emotional words, while we know that producing strong emotions doesn't necessarily require strongly emotional word expressions. You can also combine neutral words to create pretty strong emotional experiences. So in our survey paper, you will also find lots of papers categorized by these types of user information and to which type of user this is referring to. And we think this is kind of an important thing that should be mentioned in future papers when you do some sort of personalized generation. Try to be explicit about which kind of user you have in mind, which user needs are you assuming from that user, what is the type of knowledge that you're personalizing for. Other than that, we also used at different types of models that are used there and different types of evaluations. But for the sake of time, I will not go here into too much details other than saying that we found the same as everybody else concerning evaluation, that all the evaluations that we have so far are imperfect. When it comes to personalized NLG, it mostly boils down to human evaluation, and even the human evaluation is very diverse and fairly unstructured and misaligned between papers. So lots of work to do to come to some standardized and still efficient metrics for personalization. Our hopes are going towards more self-centric user evaluation, where we actually ask the users themselves what their preferences are. I'd like to talk a little bit about the challenges that we found in these hundreds of papers as kind of the most prominent. One of them being that the personalization is typically not reflected in a single message, but you need to have a large collection of the user data, and there are only very few demonstrations of the actual user characteristics in this large collection of data, which makes it very challenging for both crowdsourcing personalized type of language and for creating test sets for personalized type of language, because in both cases, you need to ask the workers to either produce sentences that have intentionally injected the personality in every segment of text, or you have to ask them to label each segment of text with certain personality or user characteristics. While in reality, we don't know in which sentences specifically or in which paragraph specifically or how often this person-specific features actually show. So this makes our models kind of artificially a bit too easy if we train on artificially always personalized data compared to the reality. Of course, personalized NLG compared to the classical or non-personalized, let's say, NLG. I don't know which one of it is more classical these days already. But personalized NLG is more vulnerable to malicious privacy attacks, of course, because you're leveraging more user-sensitive information. So it's also critical to question if we really need personalization everywhere where we can do it, or if the personalization in a given specific task has enough added value to counterweight the privacy risks. Similarly, personalized generation is subject to a large number of biases that can result through our data collection, whether the type of people that actually participate in online discussions and social networks and online platforms where you collect the personalized data, or also because of the types of people who show their personal preferences more often, while certain types of people just of specific personalities don't want to show their personalities, right? So you already get the bias from that. And you get also bias from any third-party judgments, whether it comes to evaluations or dataset creation. One tricky thing is also that the personalized NLG can lead to offensive responses. And when it's personalized offensive response, it has a higher impact than when it's like a generic offensive response, right? So if there's a chatbot which specifically for you is now rude and unfriendly, because from your data you seem to be a really rude and unfriendly person, or a translation system which, when it sounds like you, translate really more rude and unfriendly sentences to your language, you have an issue, right? And the transparency there is really important. We really need the mechanisms like what you have seen in the previous talk to have the chance to explain what we are personalizing, what's the decision process behind learning these user-centric NLG models. Those are the main takeaways from my side. So apart from structuring the user information, we mainly want to emphasize that in the future we should do this more explicitly in the papers and really think of who are the users, who are the user needs that we are referring to when we say user-centric or personalized. And we should also be cautious about the evaluation types, focusing more on really self-evaluation from the users whenever designing a task, whenever possible, and on explainability of these models. That's it from me, more in the paper. Thank you.
That was really great. Thank you, Lucie. Loads to think about, really great overview. I'm always a big fan of these papers which try to establish some order in all of the sort of slightly disordered discourse, which sort of evolves over time. And then you need to make sure you're grounding the current vocabulary in the right sort of categories. I like these type of papers. So that was really interesting. I've got a couple of follow-up questions. So you briefly mentioned that, people should really describe their target user and their target population. So are you thinking of some sort of user cards almost for people to fill out, similar to, we now have model cards and data models and things like that? Is that something you envisage, that this taxonomy could maybe be used in this way?
Oh, that would be actually really nice. But to be honest, we would already love much more basic distinction where people described what are the target end-to-end scenarios in their personalization tasks. Because when you come more from the kind of NLP head community, you tend to think of personalization often as a style paraphrasing, like going from the kind of text author perspective. When you come more from the search community, you think of personalization as the end user or recipient customization, disregarding the source. And I think drawing like end-to-end real use case pipeline, like where would contribution of my model, of my component be relevant in the future when we plug it into some system scenario, would be important to mention in the papers. Like often you have personalizations in the void in the papers, and when you then think about where is this useful, not everybody has the answer.
Yeah, no, that's a really good point. I always really liked your distinction between, like, as you say, sort of the energy style and the content, which isn't always clear what people are talking about when they talk about personalization. So I asked one last question before we then start the panel discussion. I think we are already slightly late. Just very briefly, because it sort of feeds into the panel. You already mentioned the dangers of like personalization, such as bias. So for example, there could be the case that you overgeneralize, right? So for example, women always like this particular thing, so I will always recommend them this one thing. And it's this overgeneralization obviously then also has problems like the echo chamber effect, if it's echoing like bad traits you have, or or also reinforcing stereotypes, right? So if you always recommend perfume to women or something like that. So are there active ways to sort of counterbalance this? Is there something like debiasing personalization?
I think there are many ways in terms of mathematical approaches to debiasing this. As long as you can clearly define the user group, then you can measure the kind of in between group effects and the kind of debiasing that you achieved on the model level. What I think we are doing way too little is then the practical impact of the debiasing. Like, did we actually achieve the debiased performance of the model from the user perspective? Can we plug it in somewhere and to evaluate if this really worked when we now have the formal guarantees or the metrics, the accuracy numbers that it actually worked? That's something that troubles me more than the actual debiasing approaches from the machine learning perspective.
Yeah, that's a good point. Great. So I will now proceed to the panel, and we have all the other speakers also on the panel. So there are a couple of points which I want to discuss, which I think also relates really nicely to what Lucie was saying about these different taxonomies. So one question is, so there are similarity and differences between the proposed approaches. I think especially the first 3 talks and the first 2 talks, there were a couple of things which I sort of recognized and some things which were divergent. I was wondering, do you have any ideas of listening to each other's talks about explaining to an audience roughly, how do you think they could be combining these different approaches? What are the pros and cons? Should they be combined?
If I can start. So my paper was talking more about a very short recommendation based on a very small amount of information about the user, just one conversation with an assistant, and all the other talks did have a more extensive either questionnaires or chats or filling some sort of forms. So I think those are the key differences. And, so I'm not even sure how to combine those things.
I also noticed that, sorry.
No, I think that probably we can think to merge your approach of trying to collect this kind of information and preferences about the user from the chat in something like our proposed approach. So in order to enrich our holistic user model, also with some kind of preferences that can be directly, explicitly written by the user into the chat and so on. So probably this can be a point of conjunction of merging.
Well, initially the idea was for me to do an approach for voice-based assistants like Alexa, for example, and you can't really fill out any forms in that type of setting. But I guess you can use some information of the user who is using the device.
So I guess if you're a company who has controls on how the service is provided, then you can always decide to open this option. What I'm wondering is if we can, in this sense, kind of map the neural user representations back into the explicit information that we A, get from the user and B, extract automatically, because the nice property of these things is that they are really transparent, right? So if the user tells you something, you know that he or she likes it, and if you extract something keyword-based or feature-based, then you are still fairly sure that it kind of makes sense, at least on the prototype or stereotype level of that user group. And then, then you end up with neural vectors, which are boosting the performance of your personalized system tremendously, but you're not really sure which of the stereotypes they are picking up on. And if you would find a way to map these three more obviously to make the neural system more explainable, that would be really constructive, I think.
Yeah, that was similar to the to this one comment on Andrew's talk about how could we even parse, this dialogue instead of just encoding it implicitly into vectors. Can we actually parse it and extract the user model and make it more explicit? I was also wondering whether there are two papers talking about the sort of implicit user profile construction from dialogue data, which is really interesting, and especially, as Sergey said, it applies to settings where people don't really fill out questionnaires, like in the Amazon Alexa Prize. So one thing which I was wondering, so far you've taken the chats as static, right? So basically things which user has already said. But in the real world, you've got a dialogue system which actively can ask these questions, right? Would you, thinking of this in an end-to-end in a full system, would then the system sort of learn to ask the right questions and build the user profile more interactively? Is that sort of the end vision you have for these tasks?
Yeah, that would be a great deal better. And we wanted to conduct something like this, but it's very hard to evaluate. We would need to actually create some sort of a prototype and evaluate on hundreds of users, and we just didn't have the resources for it for a short paper. But yeah, you are exactly correct. And during the Alexa Prize, we did that. So during the conversation, we learned some things about the user, and we dynamically adjusted the responses to present the more tailored, more personalized, both questions and recommendations.
Right, yeah, so Andrew.
Yeah, so I could imagine having, like we were mentioning earlier, in addition to the conversation, some background information about the user, like a questionnaire, and maybe this is automatically updated with conversation, right? When they start using the service, you could ask them to fill out some questions. As you're talking to an assistant, maybe you have edits to this questionnaire so that a user profile is maintained. Hard to evaluate, but interesting, I think.
Yeah, so that actually leads me to my next question. Lucie already mentioned the evaluation of user models is difficult, and the evaluation of personalized text is also difficult. So how do you have ideas of how to evaluate dialogue personalization then, in terms of a generalized, I'm a big fan of sort of standardized questionnaires. It's easy to evaluate on, and it's easy to compare results. Can you envision like a standardized questionnaires? Like, this is how we evaluate personalization in dialogue systems, or do you see it very much specific to different applications and different downstream tasks? I don't know whether this makes sense.
Yeah, I'm thinking one thing that would be helpful to separate is this self-evaluation perspective from the external perspective, because the self-evaluation is kind of similar to usefulness evaluation, similar to information usefulness evaluation, right? So coming from the search background, you want to kind of check, was this personalization important for the person who used the system? And then you could have kind of standardized usefulness feedback to the personalized system, no matter what you're personalizing. And then a second standardized part could be the external evaluation, like how do you perceive this this adaptation of the text given the examples that we are presenting you, with the source data that we are presenting you. Yeah, that would be beyond the scope of this discussion to come up with a framework, I fear.
Yeah, sure. Yeah.
Yeah, I think that it's always very difficult to try to evaluate a conversational agent because there are many things probably that we have to evaluate in a different way. So, for example, we have to evaluate the learning curve, or we can evaluate the accuracy of the results that are provided. So probably, yeah, I think that also in our cases, we decided to use some standard questionnaires like SUS or like Attractive in order to try to evaluate this kind of aspects, because by using offline evaluation, probably the only thing that is possible to try to evaluate is how much good are the recommendations of the personalized service that we provide, but we cannot also evaluate all the other beyond accuracy metrics, I think.
Yeah, I agree. Evaluating dialogue agent is very hard, especially you never know what exactly the user is really paying attention to and what they're really evaluating.
I always refer everybody to the papers from your group. So the 2020 INLG discussion has been a very good one on this topic. Thank you.
Thanks, Lucie. That's very nice. Yeah. It's basically a paper saying, oh, we are all very confused and we all need to agree on measures we should measure and also what these measurements mean. So I've got a couple of questions around. So you all actually briefly mentioned things around ethical concerns for personalizations and the positives and the negatives which personalization can bring. I also noticed that, you know, in your user models or user profiles, you did include slightly different features. So some included more demographic features, some just included named entities, which the user mentioned. So with this in mind, I was wondering, what do you think is there like a set of what should be personalized, what shouldn't be personalized, and what sort of user information should you use, and which user information is the user information you possibly shouldn't use? And again, is that task specific, or are there more like sort of general guidelines of what's acceptable or what's not with respect to privacy? Or is there maybe a trade-off between, you know, like maybe some information is sensitive about health, but also necessary to give the best results? And similarly with demographic information, is that always necessary, or what are the dangers of using these different types of information?
Again, so I think that we should circle back, not circle back, but start talking about the fairness in AI, which is a big topic in the last couple of years. And just people can decide which attributes should be protected and not taken into account, and which attributes are fair game. And I think that would be a good start.
So you're basically saying the user needs to have access to their user profile. Similarly to what we heard from Marco, they need to be able to sort of audit what's there and know what the system knows about themselves, delete it, or even in the first place. I mean, there are also, what I'm also trying to allude to is like there are some things where you don't explicitly, you construct a user profile, right? You don't actually know whether this user, let's say, is of a certain age range, but from their behavior, you sort of try and estimate their age range, for example, right? It's something the user hasn't explicitly provided, but you need it for your personalization. Should that be done? And if you're doing it, should that be something which the user needs to be explicitly being aware of, or also explicitly be able to edit, delete, and so on? Or should we just stick to like what the user actually explicitly provided us? I guess that relates to also your approaches about what Andrew mentioned about the explicit questionnaire I explicitly give you this information, or I implicitly chat about stuff, and suddenly, bang, the system all talks about Mallorca because I mentioned that I like to go to the Balearics at some point, right?
Yeah, I think this is kind of changing over time, the sensitivity to what we are comfortable with personally.
Yep. Lucie, I think
In retrieval, where at the beginning we would all get the same document returned, and then nowadays we couldn't imagine that we look for pizzeria and we don't get the answer which is in our neighborhood, right? But if you would get just the most frequent visited pizzeria in New York or Shanghai, you would feel very surprised. So it can be that this trend is kind of coming towards us in NLG as well, getting used to having personalized data used. But of course, it's still a difficult topic.
So what about then sort of the famous echo chamber argument, right? So if I over-personalize, I might actually reinforce things which, I mean, there are good ways of personalization, like, okay, I get the pizzeria next to me, but what if the model really sort of hones on, I'm a woman and I'm a certain age range, so I suddenly only get, anti-aging beauty recommendations, which, might be that, okay, it might make me very concerned about my appearance or something like that. So, there could be these negative effects, and we all know these more severe examples from Facebook about political echo chambers. So do you have any views on, what should then be personalized and what shouldn't be personalized? And do we also need to basically, instead of always sort of ranking the most likely item the highest, do we also need to maybe shuffle things up a bit and present you something which is not necessarily in your comfort zone? Like, they do now in social media, or they're supposed to do at least, that they always present you with some non-personalized, for example, news item.
Yeah, I think that it's important to include also into this kind of systems the serendipity. So the best idea, from my opinion, is that we should provide to the final user not only personalized systems, but also into them also some non-personalized systems, non-personalized services, in order to allow the user to explore something new.
And how is that feasible within those framework? Is that basically then just a matter of re-ranking things, like bumping things up from lower down the list? Sorry, I'm slightly outside your area, so I'm asking all these slightly naive questions.
Verena, just to remark, I think that some of the speakers already need to leave the
Okay.
session. So,
okay.
So maybe we need to kind of wrap.
Thank you for reminding me about timekeeping. I was sort of waiting for a signal to say, okay, now the time is to end the panel. But I want to finally just thank you again for participating at this discussion. And thank you, Andre, for the technical support. And have a great time at the rest of the conference.
Thank you.
Yeah, thanks
you.
everyone
Goodbye.
for joining.
Thanks.
Thank you.
Thank you.
I hope
Bye.
we can follow up this discussion at some point in person. Yep.
Exactly.
Or virtually.
Bye.
Bye.
Thank you. Bye.
Bye.